Today we're on day 3 of the first set of notes, so we're going to finally finish this set of notes so that we are able to move on. Just like yesterday's video, I'm going to start with a warm-up, so take a moment, pause the video, flip your notes over, try these 2 warm-up problems, and then when you're ready, hit play, and I'm going to work through the solutions so that you can see how you did. So for this first one, I'm going to suggest that we kind of work underneath the radical and see what we can simplify underneath there. So I know x to this 4th is the same thing as saying x squared times an x squared. And I'm going to split up y cubed to be y squared times y. And you're probably asking yourself why I'm doing that. So remember, it's implied to be a 2 out here on the square root. So if I can get these in groups of 2's, I know that they can cancel out. So this first set, the square root of x squared, will leave me with a regular x out front. The next group, the square root of x squared, will leave me with another x out front. The square root of y squared will give me a y out front. However, the last term, the square root of y, I can't take the square root of it. This is y to the first power, but I could say that this becomes y to the 1/2 power. And then this whole thing becomes to the 1/3 power. And again, you might have gone about it a completely different way, and that's fine. I'm trying to show you that there's different ways to do these problems and still get the right answer. So I'm going to condense all of this in here. So this will become x squared. I can view this as a 2 over 2. So this will become y to the 3/2 power. And then I'm raising it to the 1/3 power, so we know we multiply those exponents in, so that means I'll get x to the 2/3 and y to the 1/2 because the 3's would cancel. So that is the final answer for the first one. And again, you might have gone about it a different way, and that's totally fine. So letter B. We want to combine our terms that have the same base, and to do that we add our exponents. So x I'm doing -2 plus 5, and for the y I'm doing 3 plus a -7. So I'll get x to the 3rd power and y to the -4th power. So I'm not allowed to leave negative exponents, so I need to fix that. So this x cubed stays where it's at. The y to the -4th power would become 1 over y to the +4th power. And now I know that I can multiply this all together, and I would get x cubed over y to the 4th power. So you can kind of skip this intermediate step if you understand that this whole thing works together as a whole. So when I move that y to the 4th down, that the x cubed remains on top. All right, so now to do the examples for today. Again, I suggest that we work inside this parenthesis first. Also, a new strategy I'm going to talk about, and we might have gone over this in class already, I'm not sure, is I'm going to change this -8 to be, hold on, it looks like there's a fraction there. Let me zoom in real quick. All right, so there is, couldn't see it on my photocopy, so it's 2/3. So we're going to change this -8 to be -2 to the 3rd power. -2 to the 3rd power is -8, so I have not changed anything about the problem. I just simply rewrote it with a smaller base. This x is x to the 1st power, and this quantity of x, y, is raised to the 1/2 power because that is underneath the radical. And now if I have a product raised to a power, I know I would give them each their own exponent. So I'll have x to the 1/2, y to the 1/2, all raised to the 2/3. And last thing I would want to do is combine those x's. So I have -2 to the 3rd power. This 1 right here for that x could be viewed as a 2 over 2. So that'll be x to the 3/2, y to the 1/2, and then this whole thing's raised to the 2/3. So now, again, I'm writing a product to a power. So all of these exponents get multiplied by the 2/3. So my -2, I'll have 3 times 2/3. And then x, I'll have 3/2 times 2/3. And then the y will be 1/2 times 2/3. So we can do a lot of canceling out here. So for the first time, those 3's can cancel. So I'm at -2 to the second power. My x's, all of them cancel, so I'm left with x to the first power. And for my y's, those 2's can cancel, so I'm left with y to the 1/3. So last thing I would say to do is replace, don't leave an answer with a -2 to the second power, change that to say 4xy to the 1/3. And that is our final answer for the first one. So let's go ahead and try the second one. So the second one, I have 16y to the -8 raised to -3/4. So again, I'm going to change that 16 to say 2 to the 4th power. Again, 16 is 4 squared, but we always want to choose our smallest base. So 2 to the 4th power is the same thing as saying 16. And then I have y to the -8. And this whole thing's raised to -3/4. So now I want to handle the fact that it is a power product raised to a power. So I'm going to distribute those powers in. So I have 2 to the 4th times -3/4. And then I'm going to have y to the -8 times -3/4. So for this first quantity, those 4's are canceling. So I'm left with 2 to the -3rd. Over here, -8, let's look at -8/1. So -8 times -3 is a positive 24/4, which I know will become 6. So now I'm at the point where I need to fix this. So the 2 to the -cubed is what's going to move below. The y to the 6 has a positive exponent, so it stays where it's at. And then my final answer would be y to the 6 over 8, because 2 times 2 times 2 is 8. Final answer. Again, some of you might have said, well, could I have rewritten the original problem as 16 over y to the 8th to start the problem? Absolutely. Like I said, there's a couple different ways to go about these problems and still get the correct answer. So I would like you to try the bottom 2 on your set of notes, and we will go over those answers.